Hey there, Chem Squad. Today we're going to talk about the strength of acids and bases. Most of you already know that acids are pretty corrosive, um, but some of you guys probably still hold on to the misconception that bases are not. Okay, and in fact, both of them can be corrosive. It just depends on what substance it's exposed to and perhaps the concentration of acids and bases that you're using. So in this lesson, we'll look at what makes an acid strong and what makes a base strong. So acids generally produce H plus ions. Okay? And usually in water, which it normally is in water, they will produce the hydronium ion. So we'll just put in brackets H0 plus. Bases, on the other hand, produce OH ions, which are called hydroxide ions. Okay. When the two of these combine together, okay, so when you take an acid and you mix it in with a base, we know that it's like taking H pluses and combining with OH. It's going to create water. Now, water is not the only product. The byproduct from mixing acids and bases is a salt. Okay. So we know that H plus and OH will give us H2O. The salt depends on what anion and cation that the acids and bases contain. So it's an ionic compound. Okay. Now, this we understand as a neutralization reaction. An acid can neutralize a base, or a base can neutralize an acid. But the strength at which it does that, okay, is really dependent on whether or not the strength of the acid and base are equal to each other. Okay. Now, when they're apart, we know that acids can be corrosive. Okay. But most people don't understand that bases are just as corrosive. So both of them can corrode. And they can corrode a variety of things. So on the right-hand side here, you'll see some images. You'll see that you have a metal container that's been rusting, okay, due to different types of acids and elements that it's coming into contact with. You see the battery acids is corroding, okay, and leaking through its casing. If we go down a little bit more, you'll see that acids also have an effect on biological matter. Okay, it can corrode organic matter just as well as inorganic. And we can also see that acids and bases can also break down minerals, okay, such as the ones that form your teeth. So we're here today to look at, well, how does this happen? What causes it to be that strong in order to corrode? So if we look at what it can corrode, acids can corrode metals, it can corrode organic matter, and it could also corrode minerals. Excuse me, which are just other elements. But it all depends on what it's reacting with. So, for example, acids added to metals will generally produce hydrogen gas. and other byproducts. Oops. Okay. But hydrogen gas is the major one. So things like zinc, iron, okay, these are metals that tend to react with acids to produce hydrogen gas. However, acids do not react with copper to form hydrogen gas. Okay. Generally, copper is a pretty stable transition metal. Okay. The only substance that's acidic that will ever react with copper is actually nitric acid. So HNO3, which equals nitric acid. In the future, I'll show you what happens when you take a little bit of nitric acid and you react it with copper. It actually produces some gases that are toxic to humans, okay? And in my opinion, a little bit more dangerous than hydrogen gas. But again, we'll kind of talk about that in a future lesson. So when we're considering acid strength, we have to consider what it's reacting with, okay? We also have to consider other factors too, okay? And one such factor is concentration. So acids and bases can corrode materials quickly or slowly, depending on molarity, which is basically concentration. So if we have acids that are, let's say, rather weak, okay, so HCl at 1 molar versus HCl at 6 molar. Okay, this one would corrode metals more quickly. Whereas this concentration here is similar to the concentration of hydrochloric acid in your stomach, okay, and it typically doesn't really corrode very quickly, so it corrodes metal slowly. They both corrode, but based on their molarity and concentration, the speed is affected. Okay, so typically we do say that if you have greater concentration, it's a stronger acid. Okay, so the, the strength of the acid is much more compared to a 1 molar. And typically the last factor that we look at is whether or not it's a strong or weak electrolyte. And since we've been using acids as our example here, okay, let's stick with some acids. So if you had a strong acid, like HCl, we know this is a strong electrolyte and therefore a strong acid, and you compared it to vinegar, okay, CH3COOH, which is considered to be a weak acid or a weak electrolyte. Okay. One of the contributing factors to how well it corrodes is, again, how much H plus ions are produced, okay, how many electrolytes are created. So for a strong acid here, you have many H plus ions formed. While we know that for vinegar, you have few H plus ions formed. So between the two, this is more corrosive. And your weak acids are less corrosive. But be careful, because just like in the previous factor, when you look at molarity, molarity changes everything. Okay, if we had a very dilute solution of HCl and a very concentrated solution of vinegar, we might find that the vinegar will be stronger than hydrochloric acid. So ultimately, when we look at how things corrode, okay, we do look at the reaction itself and the type of substance that we're using. We look at their molarity, and we look at whether it's a strong or weak electrolyte. So to summarize, the strength of an acid depends on the following. Okay. When you go back to what we had looked at before, depends on what it's reacting with. So it depends on the depends on the chemical nature of the reactant, or let's say of the reacting acid. And what it is reacting with. Because you can have a very strong acid, and if it's placed with something that it doesn't react with, it's not very strong, or you won't get a very vigorous reaction. It depends on the molarity. Okay, of your acid. And finally, it depends on the ability of the acid to produce H plus ions. So is it a strong or weak electrolyte? So these three things here all help to determine and shape how strong an acid might be, okay, or might appear to be. And we'll make a little note here that for bases, the hydroxide ion is the factor instead of H+. So is the major factor instead of H+. Okay. Now, we do have a table that charts everything, okay, to give you a ranking system to see which acids and bases are stronger than others. So it's in your periodic table package, and it'll look something like this. So it'll say Ka table, relative strength of acids and water. So this one here, of course, deals with only acids. I don't have one for bases, okay, but I'll tell you a little bit later on how we can use this to help predict what type of bases could be strong and what are considered to be weak bases. So if you look at excuse me, if you look at this chart here, you'll see a couple of things. I wouldn't worry too much about the Ka value, okay, this column just yet. Okay, we'll get to what it actually means, but how you read this particular table is all of your very strong acids are at the very top. Okay, so the strongest acid that we know of is called perchloric acid, and if you kind of scroll down until you start recognizing certain acids that we use in the lab, okay, you won't find hydrochloric acid until number 4 here. Okay, so we have hydrochloric that we typically use. You don't use nitric acid as much, but we do use sulfuric. Okay, so acids 4 to 6 are pretty common in our lab. Okay, so they're quite strong. So if you want to compare that with a weaker acid, well, if you keep scrolling down, you won't find the weak acids until you get to number 19. So what I want you to do is, I do want you to highlight acetic acid here. Okay. Acetic acid is your first weak acid. Okay, and out of all the weak acids, it's actually the strongest weak acid. When you go down further, you'll notice that you have water here as well as reference. Okay, so we know that water is neutral. So the weakest acid that we have is number 30, which is hydrogen sulfide ions. Okay, and then you have water, neutral, and then there are 2 representative of your bases. Okay, down at the bottom. So you have the hydroxide ion, and then you have ammonia. Okay, these guys are considered to be bases. Okay, and if we were to use acid terms, these are the weakest substances that we would even consider to be acids. Okay, only because both these ions have the ability to produce H+ ions. Okay, now what you guys are responsible for knowing is where acetic acid is, okay, in this list here, and that it is one of the strongest of the weak acids. Okay, and later on we'll go back to this diagram and explain the whole thing about the Ka values. But for now, just realize that acetic acid is a strong weak acid, and some of the more common acids that we generally use are at the top here, starting with hydrochloric. Okay, so I guess you can also highlight that as well, okay, just so that you can find them a little bit more easily on your table here. All right, that's all I have for today. I hope to do a few more labs with you regarding acids and bases for this unit. So I will see you then. Take care, guys.